Okay, we've learned something in the prior sections of Chapter 8 about confidence intervals for sample proportions and for sample means. We're talking about their probability distributions. Now we actually have to figure out how big to make our n. So you're going to actually need to know your algebra pretty well. You'll see that in just another page or two here. So we have to decide on our margin of error, how small a interval estimate we want. And we want to know how confident we want to be. In practice, we usually use 95% confidence intervals, so that's not a hard part of it. Now this formula is shown in the notes that I gave you, the handwritten notes for Chapter 5, 6, 7, 8. The m on the bottom refers to the margin of error. So you're going to pick some margin of error, and the p hat on top refers to the sample proportion. But we don't know the sample proportion, so we have to put something in there. So we consider the bigger the top is, the bigger n is. And you know the bigger n is, the better chance we have of actually being correct. So how do we maximize the top? Well, the z that we're squaring is 1.96 to get 95% confidence interval. The 1 is set, so the only thing we can change is the p hat. If we pick numbers like 0.2 for p hat, then 1 minus p hat is 0.8. And when you multiply that, you get a smaller number than if you pick the absolute best. You get a big number, and that absolute best is 0.5. Then you're multiplying 0.5 times 1 minus 0.5, so you get 0.5 times 0.5 or 0.25. That's the biggest you can make that part of the term that's on the top. So that's considered safe. So you'll see that listed at the bottom as a safe approach, and I would recommend doing that. So our example is about an election that's supposed to be close. And since it's close, adding or subtracting a margin of error of 4% is simply too large. So we're going to go for a smaller margin of error of 2%. We're going to do the calculation. So we simply plug in 0.5 for p hat. We plug in 1.96 for z. On the bottom for the margin of error we put 0.02. And we do the math and we get 2,401. Now you might be tempted to do something like make it 2,400. But if you do that, your sample size will actually be too small. So you have to be careful on the rounding. If you had a decimal portion, you always round up. Rounding down will give you something that won't be quite the correct size. Now when we do this for a population mean, you show here a different formula for finding m. The z is still the same, the m is still the same. Now we have sigma squared. Problem being, we don't know mu and we don't know sigma, so we have to put something in there. So guess what we're going to put in there? Well, we're going to do some crude estimate, meaning it's okay, but it's not great. So we're going to estimate a range of the data. Estimate the range of the data for a bell-shaped distribution. So almost all of it will fall within 3 standard deviations. So you'll see here how it works. So if we have a margin of error of 1 year, we put 1 on the bottom. For sigma, they're going to have 3, and they're going to square it, 1.96 for the z. Now you can change some of these sigmas depending on how you think things are, and you can check different things. And I'll show you how to do some of that in class. So you have to remember, you have to think about your margin of error, your confidence level, how much the data varies, and so when you take your sample, you may not get exactly what you're thinking you're going to get, and how much it costs to do the study. So when n is small, you need to be cautious, looking at outliers, and you have to do your testing for at least 15 for the approximation for the number of successes and failures. Here it shows you your point estimate of p hat plus or minus the margin of error. The margin of error is simply z times the standard error. And for a proportion sample, it's the standard error is the square root of the quantity p hat times 1 minus p hat over n. Now if we do this, and we add 2 to the number of successes and 2 to the number of failures, it turns out that that actually can help us to make sure that we hit the qualification of having at least 15 successes and 15 failures. We're adding the same amount to each side so it doesn't change it. by each side, the number of successes and the number of failures. And that finishes our section 8.4. 8.5 we can read, but we're not really going to concentrate on that.